Say my bride, let's go for a ride in my newfangled automobile. Just where we will go, nobody knows, but it's sure a great way to feel. Behind the wheel of the speed meter steel, it's my newfangled automobile. Hello and welcome to Vintage Car History. I'm Wild Bill. Though it is true that in today's world there are some makes of cars that are hand-built, the vast majority of cars found in the dealerships across the planet are made in large factories which are controlled by computers and where the heavy work of assembling a car is being performed by robots. And though we may marvel at the modern technology being applied to automotive manufacturing, it is just as astounding to look at how the automotive industry actually achieved this. For the historical tale of the modern car factory begins long ago. So we're going to take a look at how humanity learned how to make lots of cars. The place to start is the Stone Age. To make a car, the principles of manufacturing must be applied. The ability to make multiple samples of the same or similar component. When mankind began to make stone tools, we made them for specific purposes, and they all share similar traits. Populations of ancient peoples are often identified by the type and style of tools they made. And studying these tools demonstrates advances in technology in the days before recorded history. And there is no doubt that these various cultures also made tools from wood, animal bone, antler, horns, skins, and other such things, though examples of these types of tools are extraordinarily rare to find. Nonetheless, it is known that the earliest forms of carpentry come from this period, and lots of wood was used in making cars back in the day, as well as leather. Leather tanning technology dates from this period of prehistory and is still used in cars today. The next major advance in manufacturing technology was the development of basic metallurgy. This began in what is often called the Chalcolithic period, which is when civilizations began to work metals some 8,000-ish years ago. As far as we know, the first type of metal work was cold forging. Back then, a few metals could be found just lying around on the ground. Natural gold can be worked rather easily with stone or antler tools. Without needing to heat the gold, shiny ornaments could be made, the first cold forging. Copper could also sometimes be found already pure enough to be worked in this way, though it took much more effort as copper is not as soft as gold. Not long after this, the concept of smelting was invented. Some genius had the idea of heating rocks that had lots of metal in them to get rid of the impurities and extract the metals trapped in them. This process made many more metals available in quantity: copper, lead, tin, silver, and even iron. Copper and lead were the first to be used widely, as they can be extracted from ore at lower temperatures than others. Getting these metals hot and then beating them into submission was the beginning of hot forging, which is the basis of blacksmithing. Smelting also led to another new technology: casting. Casting is basically pouring molten metal into a mold. Once it cools, the metal is removed from the mold and it retains the shape given. Several methods of casting were invented early on: the lost wax process, sand molds, ceramic molds, and were using copper as their primary metal. Casting could allow for many reasonably identical metal objects to be made with molds, though the process was imperfect at best, and often the copper would not flow properly through the mold, requiring the caster to remelt the metal and try again. All this hot metal led to the next major advance in future car manufacturing: alloys. The first major alloy, bronze, was so innovating they named a whole historical epoch after it. By adding tin to copper, combined with a bit more heat, it not only was harder than copper, but flowed into molds easier, and was also easier to work on an anvil. To get more heat, kilns were invented and improved upon to get purer metals and produce better quality of bronze. Tools and weapons made from this alloy proliferated throughout the ancient world. Another invention around this time was the spoked wheel, the combination of carpentry, casting, and forging. A bearing for the axle would be cast, the spokes could be carved, and the bronze tire could be forged. Future cars would have wheels made with these basic components. At about the same time, glass was invented. Glass is made by taking silicates, like the ones commonly found in sand, and melting them in a kiln. The result can be cast in a mold or worked with tools when hot, like a smith would do with metal, though the techniques and tools used are quite different. Glass was first used for jewelry, but the technology grew to include bottles, bowls, cups, and, though uncommon, windows. Making glass clear enough for use on a car would take a while, but the basic technology is quite ancient. Iron was the next major component of car manufacturing to make the steam. It takes a lot more heat to smelt iron than it does copper and tin. And when iron began to be first worked some 4,000 years ago, it was actually not smelted per se. Rather, the ore was put into a bloomery, essentially an early form of furnace. The bloomery had a fire in it and a thick earthen wall to keep in the heat. Also, a vent was near the base where another invention could be used, the bellows, to increase the heat of the fire. The resulting iron would be mostly clean of the impurities, but itself didn't actually melt. Once everything cooled down, under the ashes of the fire would be a ball of spongy iron, a bloom, which in turn could be heated again and worked on an anvil with a hammer. The result was, and still is, wrought iron. But to make a car, you're going to need steel. Wrought iron is strong, but can be somewhat brittle, which does limit the applications for its use. Steel is made when more carbon is added to iron, which in turn reduces the brittleness. To do this, a bloom of iron was placed in a crucible, a dense ceramic bowl that would not melt or break in the heat. Bloom of iron placed into it along with a carbon source, often charcoal or coke. Once it's nice and hot, it can be casted in a mold or forged on an anvil. Steel could be made with different amounts of carbon along with other additives, which would give the resulting steel different properties. The first people to produce steel in large commercial quantities lived in India some 2,500 years ago. These folks came up with a primitive form of blast furnace, a large kiln that held multiple crucibles while having a continuous source of air being forced into the fires. Their steel was quite renowned in the ancient world for its quality. Furnaces themselves would continue to develop in both ability to get nice and hot, as well as capacity to heat lots of steel at once. This is good, because cars do need lots of steel. Another thing you'll need in order to make cars is a place to make them. A facility where machines are used to produce a product. Such facilities, or factories, could be a small one-man operation or a large concern with dozens of workers. Factories have been around since the first millennium BC, the early ones being powered by water wheels or wind power. These early factories were often used for milling grain, the water wheels powering millstones. But factories with trip hammers for forging, as well as crushing stone for concrete and other applications, were not uncommon. But to have a factory that's capable of making cars, you will need machine tools. Prior to the Middle Ages, factory workers used hand tools to finish their work. Hammers and chisels can be satisfying to use, but they are not consistently accurate. They are dependent on the skilled eye and steady hand of the worker, which varies from person to person. A machine tool instead relies on mechanical guides to do the work of cutting and shaping metal. And the first use of them begins in the late 13th century with the production of clocks. These early machine tools were basically mechanically guided bevel grinders, able to cut gears for a clock with great precision. This made it possible to make not just one handmade clock at a time, but many clocks that would use the same gears. Now, to be fair, the demand for clocks at this time was not huge. They were still state-of-the-art technology and too expensive for the common man. Nonetheless, the machining involved in their manufacture was the first primitive expression of what would someday become mass production. More machine tools would follow. The emerging firearm industry, cannons, mortars, and handguns, needed new machine tools to make. Thus, the lathe and boring machine were invented. By the beginning of the Industrial Revolution, many of the basic machines that could be found in a modern machine shop had been, at least in their most basic form, invented. Borers, lathes, drill presses, precision grinders, and cutters could be found in factories all over Europe. All of these machine tools are critical in the manufacture of cars. Speaking of the Industrial Revolution, it was made possible by the invention of the steam engine. By 1800, factories powered by engines that were made with machine tools were now themselves able to power factories that made machine tools and much, much more. Advances in metallurgy made both the machines and their products more reliable and durable. As a result, factories were able to produce far more products and with much greater uniformity, which leads to the next major advance in manufacturing: interchangeable parts. Though many products from many industries used and benefited from the principle of interchangeable parts, it was the firearm and sewing machine industries that were prime movers to make it happen. Both are fairly complex machines where the actions of its working must be timed with precision. In the middle of the 19th century, the development of specialized machine tools were part of their manufacture. A machine was designed and built to only do one or very few specific tasks. This would be typically making a particular part for the sewing machine or gun. Other machines would make other parts, and so a factory worker could just take the various parts out of a bag and build the machine or gun they needed. Mass production was truly born. A broken gun in the battlefield or a sewing machine at the tailor's shop could be repaired easily. Spare parts were now available, not needing to be handmade. And many industries benefited by what these machines could do in manufacturing. Among the first in the lineage of automotive manufacture to reap these benefits was the building of coaches and carriages. These makers of horse-drawn vehicles began to rely heavily on mass production. They could buy wheels already made, axles that would fit properly, and springing ready to go. They could even buy leather upholstered seats right off the shelf, add them to their own parts, be they of metal or wood, and they could make vehicles of a specific and repeatable design to make a model of a carriage. By the 1870s, a new invention, the bicycle, had entered the scene, and these advances in manufacture made them quite prolific. Components such as gears, chains, and wheels could be purchased from other companies that focused on making them for other folks to do something with. Bike builders sprang up everywhere, supported by not only the factories making key parts, but also their own resources. Factories with the tools to move metal in the form needed for bicycles. Like the coach and carriage makers, bicycle makers now had the resources of supply and tools that would make their vehicles unique. The manufacture of what most historians agree are cars began in Germany in 1885. Two cars were built by two different men, Karl Benz and Gottlieb Daimler, and they each took a different approach to their manufacture. Karl built his cars based on bicycle technology. The wheels were off-the-shelf bike wheels, and the frame of the car looked much like what could be found on contemporary cycles. His car was light and also hand-built. In his workshop, Benz had, of course, machine tools and managed to make his own engine for the car, as well as the frame, transmission, and steering system. The seat he bought off the shelf from a general store. Daimler reached out to the carriage industry. He bought a carriage, took it home, and used it to make his car. The engine was his own design and made in his shop, as was the transmission. The rest of the car was stock carriage. Initially, this is all Gottlieb wanted to do: prove that the engine design worked so that he could sell engines to anyone for whatever application, be it a car or something else. Thus he began tooling his factory for making engines. And someone in France decided to buy them and make lots of cars: Armand Peugeot. Peugeot was the first man to truly mass-produce cars. He started with steam cars in 1889, but was making gas ones by 1891 using Daimler engines. His manufacturing method was simple. Buy as many components off the shelf as he could, wheels, gears, seats, and whatnot, and the components that he couldn't buy he'd make on site. His cars were built a few at a time as space allowed and the speed of his factory team. The workers would fabricate the chassis and then make the parts to go on to that specific car, as well as install those parts that were pre-made elsewhere and delivered. The speed of manufacture was not great, a couple cars a week in good weather, but they were all fairly similar and recognizable as specific models. This rather cumbersome method of making cars made them quite expensive, as the amount of time it took to make one, coupled with the costly technology involved, pushed the price tag of the final product beyond the reach of the man of modest means. But new manufacturing processes were on the horizon, and they came rather suddenly in both France and the USA. Companies like Peugeot, Panhard & Levasseur, Didion Bouton, Renault, Winton, and Oldsmobile all rather independently developed the first automotive assembly lines. Here's how they worked. Inside the factory there were multiple stations with various tools. Some factories could have 50 or more such stations. One crew would go to each station and leave a chassis. Then the next crew would go through and add wheels and axles. The next crew would bolt on the engine, and so on. Different specialized crews would go to a station, do whatever they were to do for the construction of the car until the car was complete and a new bare chassis took its place. Many companies, like Winton and Didion Bouton, were able to produce over 1,000 cars in 1 year before the turn of the 20th century using this manufacturing method. By 1900, many car makers had brought most of the manufacturing process in-house, making their own engines, transmissions, brakes, suspension, and whatnot. Others continued to bring component parts in from other companies and assemble them into a car. But the first methods of car manufacture, making parts for a specific chassis, made the resulting car rather unique. Though they may look like other cars from the same factory, their parts needed some hand fitting due to the slight variations in parts manufacture. There were two different methods tried to solve this issue, and both were successful. One was to design the car so that the parts didn't need to be completely precise, famously perfected by Ransom Eli Olds. The other was to make the parts so precise that any part would work on any car. The latter is what was spearheaded by Henry Leland, an old-school gunmaker that believed that his cars, the Cadillac, would have absolute parts interchangeability. Leland made all of his parts as well as his own specialized machine tools and templates for them. On his assembly line, no hand fitting was needed. Every part fit just right, no matter what chassis it was being put on. His standards were exacting but paid off. His first cars were single-cylinder light cars, yet built to that standard, to the extent that Cadillac won the Dewar Trophy in 1908. This trophy was awarded by the Royal Automobile Club in England for outstanding performance in the industry, and here's how Cadillac won it. First, they sent over 3 1907 Model K Caddies. The 3 were then driven around a test track for some 30 miles. Next, they drove them into a garage where some mechanics completely disassembled the cars down to the nuts, bolts, and wires. Then they took all of the parts and mixed them all together. A day or so later, a new team of mechanics were required to rebuild 3 cars from the pile before them using just hammers, wrenches, and screwdrivers. No refitting tools allowed. After a day of assembly, all 3 cars were back together. They all started up with no problem and then went on to participate in a 500-mile race in which all finished and one of them was first in its class. This was absolutely groundbreaking in automotive manufacturing. It is true that today one can go to a local parts store and buy a part for just about any make and model of car, but it all started with Henry Leland and Cadillac. Perhaps the most famous advance in automotive manufacturing was the application of the moving assembly line, which was first implemented in a Chicago slaughterhouse. Let me explain. One of Ford's financial partners, a Mr. Pat Klon, visited the Swift and Company slaughterhouse in Chicago. What was unique about this slaughterhouse was how they butchered their cattle and hogs. The carcasses were hung from hooks, but the hooks were themselves attached to a thin chain, which itself was attached to the roof. The meat was slowly moved across the cutting floor, where a butcher would take off a specific cut of meat, and then it would move on to the next butcher. The people stayed where they were and did a specific task, with the work being brought to them mechanically. Klahn explained this idea to Henry Ford, and between them came up with a plan. A Model T chassis would be put on a conveyor and sent across the factory on a schedule. Specialized teams of assemblers would stay in one place along the line and do a specific task to the chassis until, at the end of the assembly line, the car was complete. In order to keep his teams energized, Ford instituted the first minimum wage as well as the 8-hour workday. This reduced worker fatigue, and the higher wages made his own employees able to buy Fords, and his employees were very loyal to Ford as a result. The modern auto industry is, for the most part, based on the manufacturing model that was devised by Pat Klahn and Henry Ford. Of course, in today's world, much of the work is done by robots, yet the idea behind that moving assembly line actually came from an abattoir. And the making of cars as a whole came from a long history of people just wanting to make things, lots of things, since the dawn of time. Thanks for watching Vintage Car History, and we'll see you next week. Peace.